All right, guys, so today we're going to revisit a word we're pretty familiar with. I think we learned about it earlier in the year, and I think it stuck with you, the word equivalent. All right, equivalent simply means when two numbers look different and sound different, but they're really equal in value. We learned, and again, equivalent has kind of that equal at the beginning there. And when we talked about equivalent in the beginning of the year, we were focusing on equivalent decimals, right? And equivalent decimals are simply decimals that look different and sound different, but are equal in value. For example, 3 and 67 hundredths and 3 and 670 thousandths, having nothing in the thousands place and having a zero in the thousands place mean the same thing, making the decimals look different, sound different, but really mean the same thing. Obviously, we're not working with decimals anymore. We're working with fractions. So today's lesson is going to be on how to understand and make equivalent fractions. Fractions that look different and sound different when you say them, but really are equal in value. They mean the same thing. So to make an equivalent decimal, we know that all we need to do is just annex a zero into an empty Thuniverse place value, and you create an equivalent decimal. Well, now we're working with equivalent fractions. To make an equivalent fraction, you're not annexing a zero. Instead, you simply watudamadud. That's right, I said it, watudamadud. So what does watudamadud mean? Well, watudamadud stands for whatever you do to the numerator, you must do to the denominator. So watudamadud is a verb. It is an action. It is what you do to one fraction to create an equivalent fraction, a fraction that means the same thing but looks and sounds different. Now, watudamaduds can only use two operations, either multiplication or division. And when you're using multiplication to watudamadud and create an equivalent fraction, since multiplication makes numbers get bigger, multiplying will make the numerator and the denominator both bigger, but it will keep the value of the fraction the same. When you watudamadud with division, because division makes numbers get smaller, we're going to be making the numerator and denominator smaller, but still keeping the meaning of the fraction equivalent or the same. Today, we are only going to work on watudamadudding with multiplication. It's definitely the easier one and really important. So let's say I give you the fraction we're most comfortable with, 1/2. And I want to come up with a fraction that is equivalent to 1/2, meaning it means 1/2, but it doesn't say 1/2. Well, all I need to do is watudamadud. What's really nice is when you're watudamadudding with multiplication, you can use almost any number in the entire world to watudamadud. So the watudamadud, again, is the action that happens to go from one fraction to create an equivalent fraction. So let's say that I'm going to watudamadud, again, whatever I do to the numerator, I need to do to the denominator. And let's say I'm going to choose the number 3 as my watudamadud. If I'm going to take the numerator of 1 and multiply it by 3, I need to do the exact same thing to my denominator. That is watudamadud. Whatever you do to the numerator, you do the exact same thing to the denominator. What that means is essentially 1/2 means 1 out of 2. But if I watudamadud times 3, it means I'm going to take that 1 shaded out of 2 total, and I'm going to repeat it 3 times. So you can see I now have 3 shaded. That's my new numerator because let me grab my pointer here. 1 times 3 is 3. That's how many I now have shaded out of my total that is now there, which is 6, because I had 2 total and I did it 3 times for a total of 6. And we know based on yesterday's lesson about greater than, less than, or equal to 1/2 that 3/6 also means 1/2. These two fractions are equivalent. Let's do another one. Let's say I have 2/5 and I want to create an equivalent fraction. Again, that equal sign means that they're equal in value. And I'm just going to watudamadud. This time I'm going to pick a different watudamadud. Again, whatever you do to the numerator, you need to do to the denominator. This time I'm going to pick a watudamadud of 4. So if I multiply the numerator by 4, then I have to multiply the denominator by 4. What that means is if I had 2 out of 5 shaded, 2/5, and I do that 4 times, because that's my watudamadud, now how many I have shaded is 2 times 4, which is 8. And how many total I have is 5 times 4, which is 20. Again, we're going straight across here. 2 times 4 is 8. 5 times 4 is 20. 2/5 and 8/20 are equivalent. They look different and sound different, but they mean the same thing. Let's look at one more here. Let's say I have 3/4 and I'm going to pick my Watutamudud this time. Whatever I do to the numerator, I'm going to do the denominator. I'm going to pick times 2. And if I'm going to do that to the 3, I'm going to also have to do it to the 4. So that means 3 out of 4 shaded 2 times. So now I have 3 times 2, which is 6 total shaded. And 4 times 2 is 8. Because again, if I'm going to take 3 times 2 is 6, 4 times 2 is 8. I did the same thing to the numerator that I did to the denominator, meaning I made the fraction look different and sound different, but stay worth the same amount. All right, I guess I have one more here. Let's Watutamudud this time. Whatever I do to the numerator, I need to do to the denominator. Let's do it times 5. So I have 1 out of 6 shaded. I'm going to do it 5 times. So 1 times 5, my new numerator is going to be 5 because 1 times 5 is 5. And 6, my denominator, times 5 is going to be 30. So 1/6 is equivalent to 5/30. They look different and sound different, but mean the same thing. That is how you make equivalent fractions, by Watutamududing. But I want you to understand why it works. And it all goes back to this thing called the identity property of multiplication. Think about this for a minute. If I have 5 times 1, well, it's still 5. So the identity property of multiplication means when you take a number and you multiply it by 1, it stays that number. Well, if we apply that to fractions, 3/4 times 1, well, it's 3/4. But 3/4 is not equivalent to 3/4 because they have to look different and sound different. So instead, I'm going to use what we talked about. Equivalent means looks different and sounds different, but equal in value. We know that a 1 is going to keep it the same value, but looking the same. So what I'm going to do is I'm going to think to myself, what do I know about the number 1? Well, I know that all rectangle fractions mean 1 whole. So if I just pick a random rectangle fraction, 5/5, instead of putting a 1 here, I'm going to replace it with a number that means 1, 5/5. That's essentially my Watutamudud. Again, whatever I do to my numerator, I'm going to do the same thing to my denominator. So now, if I know that 3 times 5 is 15 and 4 times 5 is 20, I am creating, with a Watutamudud that means 1, an equivalent fraction. So when we're Watutamududing, we're essentially using the identity property of multiplication. We're taking our original fraction and multiplying it by a value of 1 to create a new fraction that looks different and sounds different, but is equal in value. 3/4 is equivalent to 15/20. Again, I could choose a different Watutamudud. I know 1 whole is also the same as 2/2. So if my Watutamudud is times 2 is my numerator and times 2 is my denominator, I'm going to create an equivalent fraction. 3 times 2 is 6 and 4 times 2 is 8. So I can see here by Watutamududing, by a fraction that means 1 whole, I am keeping the meaning the same. 3/4 is equivalent to 6/8. So great news. When you want to make an equivalent fraction using multiplication of Watutamudud, you can use almost any number in the whole wide world. There are only 2 numbers you cannot use. Think for a second what it could be. Well, we know we can't use 1 because when we multiply by 1, it stays the same. We need it to look different and sound different. So we can't Watutamudud by 1. And the only other number we cannot use is 0. All other numbers are fair game with Watutamududing. So what we're going to do next is you are going to complete an activity. I'm going to show you here that, probably should have had this up and ready to rock and roll, is in the Google Classroom, and it will look like this. It will have the definition of equivalent fractions, and it will give you 2 examples. I have the original fraction, 5/6. I give you the Watutamudud. Your job is to give me the new equivalent fraction. On your dry erase board, you're going to take the original fraction 5/6 and you're going to wutudamudud, in this case, by the 2 and create your new equivalent fraction. 5 times 2 is 10, 6 times 2 is 12, and you would type that into the box under new equivalent fraction. I did another example for you. If your starting fraction is 1/4 and your wutudamudud is 4, we're starting with 1/4. We are multiplying the numerator and the denominator by the same number, 4 in this case, because that's what I told you to use. And that 4/4 means 1 whole. It's going to stay the same value. And we're simply going to multiply going across. 1 times 4 is 4. 4 times 4 is 16. So our new equivalent fraction is 4/16. You're going to do the same thing for the questions that I have here. Make sure that you turn in this activity by saying, I'm done. And that is your final assignment for today. You must come back to the Zoom when you think you're done, because I will look at your score and make sure that you're understanding the material.